Yes, class. Am I audible to all of you? Aisha, Aram, Fatima, Maha. Present?
Yes, ma'am.
Alright. So see class, in the last class we had started with graphs. Slopes we had done, all the three types of slope we have studied, a constant slope, then variable slope, if it is increasing, if it is decreasing. Then we had seen three more types of graph, if a linear equation is there, if a quadratic equation is there, and if you have inverse relation. Then one of the major graphs that we had started with was position versus time graph. So versus time graphs, the slope of position versus time graph gives you what? It gives you velocity. Here also we had seen different cases. If these cases are provided, how will the nature of graph be? Now see, position time graph, if you have this only position time graph, if it's for uniformly accelerated motion. If it's for uniformly accelerated motion. See what will happen. Velocity will change. Means you won't be having a constant graph. Velocity will change. It means your slope is variable this time. As velocity is changing, so the slope is variable. Have your schools reopened? Or are your vacations going right now? Aisha?
Ma'am, August 15, my school will do.
Okay, your school is reopening. So Aisha, till where you people had completed before beginning the vacations? Aisha, Aram, anyone can
We have stopped in the middle of vectors.
stopped in the middle of vectors. So how in your school did it go about? Means first this lesson was over, then vectors, or like this lesson is over, no?
Yes, this is over, then vectors.
Vectors in the middle of vectors. What about you, Fatima? And Maha?
Ma'am, we finished till chapter 3.
Which chapter, Maha?
We finished till chapter 3.
Chapter 3. Chapter 3, motion in a projectile. Projectile motion. Okay, that has been completed. All right. Fatima, what about you? Maha, you same thing. Same, both are in this case, same school.
Yes, ma'am.
All right. So slope is variable, and here you will get the graph which will be curved. Why? Because obviously in case of uniformly accelerated motion, what did we see? Velocity kept on changing. So if velocity changes, uniform velocity means velocity is changing in regular interval of time. So what kinds of possible graphs you get? See, one kind of graph that is possible over here. If first thing is, if velocity increases, then what will happen? See, if velocity increases, then slope also increases. All right, if velocity increases, then slope also increases. And what happens to this curve? This curve is also of the increasing graph. If this is time, this is position, then this will be the increasing graph. Secondly, if velocity decreases, then the slope will also decrease and it will be a decreasing curve. So that we had also studied. This is time, this is position. So this will be a decreasing curve. This we had studied. So do one thing, note down this part, then we will start with velocity time graph. All right, class. Now velocity time graph. So velocity versus time graph. If you have a graph which is velocity versus time. So tell me one thing. This is velocity, this is time. So obviously there will be a slope of it. Can anyone tell what the slope means? Tan theta will give me for this graph. This is slope which is equal to tan theta. What will the slope give me?
Acceleration.
Acceleration. Perfect. It will give me acceleration because this will be equal to v by time. V by time. C class. If you have no velocity versus time graph supposedly. Fine. So velocity divided by time gives you acceleration. So this is given by the slope of the graph. Suppose let's say it's acceleration versus time graph. Let's imagine this is acceleration versus time graph. How will we get the third quantity? Acceleration multiplied by time gives velocity. So whenever anything is getting multiplied, take out the area of it. And whenever two things are getting divided, take the slope of it. So that is one thing that you have to keep in mind while calculating the graphs, because then different quantities graphs will be given to you. Displacement versus time graph will be given to you. Acceleration versus time graph will be given to you, and so on. So you have to keep all these things up. So yes, slope will give the acceleration, and area of the this graph, displacement and time graph, will give you acceleration. That we'll see later on. But remember, because see, displacement is what? Velocity is displacement divided by time. So from here, tell me, how will I calculate displacement? If I multiply velocity with time, then I'll only get displacement. See from this graph. See this graph. This is velocity versus time. So velocity divided by time is giving me acceleration. And velocity into time is giving me displacement. So acceleration is given by the slope of the graph. This displacement is given by the area of the graph. I'll write down these points as well, because these graphs will be given to you in the exam. Now see, velocity versus time, if you have uniform motion. So rest of the basics remain the same. If you have to calculate, if it's a case of uniform motion and you want to find out the velocity versus time. So in case of uniform motion means acceleration is 0. So acceleration is 0, it means slope will be 0. And in the last class only we have studied what's the graph for a 0 slope. Now how to depict it? See, if velocity is somehow increasing, not increasing, positive, because acceleration is 0. So, you know, the graph will be, this is your time, this is the velocity. This will be the slope, 0 slope, parallel. See, this is parallel to the time axis. But if your velocity is negative, fine, if your velocity is negative, so how will you plot the graph? This is your velocity. This is versus time. Here you have extension of the graph. Here you will plot it because your velocity in this case is 0. Now let us see different cases. Now case 1. If the body starts from rest, let's say acceleration is positive this time, t is 0, v is 0. These were the cases we had seen. So see here what is happening. Your slope is positive. So this is v versus t. So this shows that slope is positive. This will be the nature of the graph. Simple, theta. Let's say case 2 you have. If this starts from time is equal to 0, velocity is not 0, it's positive. Somewhere it's positive. And let's say acceleration is negative. Let's take, we have made a case by ourselves because these cases can come in the exam. So this is velocity, this is versus time. Now, we cannot start velocity from the origin. Reason? Because velocity is not 0. It has a certain value. That value we are not aware of. We are just focusing on how to plot the graph. Let's say it is somewhere here. If I draw it like this will be positive slope. So I have to draw it like this. This becomes the negative slope. And this also gives the obtuse angle like this. Now, one more case, one last case. Let's see. Case 3 is if your time period, time is 0, means the starting time, initial time is 0. Let's say velocity is negative this time and acceleration is positive this time. So can anyone predict the graph? Means your slope is positive, but velocity is negative. Can anyone give an idea? This is V versus T. We have to extend it because this will lie in the negative axis. See, how will we plot it? Velocity is negative, so definitely it will be here somewhere. If I draw it like this will be negative slope. Acceleration is positive. So this becomes the slope, positive slope. Here, how to plot the graphs? If any case is given to you, will you be able to do it now? Clear or any doubts? Yes, no, what? Clear? Okay, fine. And what about you? Fatima, Aram?
Yes, ma'am, clear.
Clear?
Yes, ma'am.
So you people have noted it till here, no? From here you have to write it. Aisha, have you calculated the displacement or distance in the first part? Because you had to find out the displacement in the first part. See, let's discuss it now. For the calculation of displacement, if you see the trapezium, this is what? This is velocity versus time graph. So for getting displacement, I have to take the area of the graph because velocity multiplied by time will give me displacement. It means this shows that I have to find out the area, not the slope. Now, if you see this is a trapezium, so area of this graph will be what? This is a trapezium and this is a triangle. So calculation is easier. How to calculate the trapezium, area for trapezium? Half plus sum of parallel sides into height. So see for the first part, displacement will be equal to what? Area of trapezium. Now regarding this triangle which is formed here, let's name it something else. Let's say this is A, B, C, D, E. So this triangle DEF is below the axis. It means this will be negative. Since we are calculating displacement, we have to consider the signs. So this becomes minus area of triangle. So area of triangle becomes half into sum of parallel sides. See what are the parallel sides. One side is this, so this becomes 6. Other side is this, BC. So this is what? 2. So 2 plus 6. This is 2 plus 6. Multiplied by height, half into sum of parallel side into height. Separation between them. What is this length? Can anyone tell me the height of this trapezium? See, what will be this distance?
Five.
10. It will be 10. See this separation. This is which distance? This distance is what? This distance is 10 meter per second. So it means this separation, this is actually a straight line. This is a complete straight line. So this will be 10. Height will be 10 into 10. Now minus half into base into height. So half into base into height. So this is the base. What is this base? 10 minus 6. That gives 4. And what's the height? Height is again 10. No need to take this height as negative because we have already considered negative sign. So this becomes half into base into height. So this becomes what? Half into 8 into 10 minus half into 4 into 10. This is 80 by 2, which is 40, minus 40 by 2, which is 20. So answer for the first part is 20 meters. This is the displacement for the first part. Distance in the second part. Can anyone tell me the difference that will come while calculating distance and displacement? This is the solution for displacement. What should be the solution for distance? Anyone? Any difference that should come? Displacement is what type of quantity? Scalar, vector? Yes, Fatima, what type of quantity is distance? Scalar or vector?
Vector.
Distance is scalar. Displacement is a vector quantity. That's why we had considered this negative sign because of the negative height that was coming. Distance is a completely scalar quantity. So scalar quantity means here the area of trapezium plus area of triangle will give us the distance. If you subtract, that gives you displacement. So area of trapezium is what? 40. Area of triangle is 20. So this becomes 60 meters. Why are we taking the area? Again, we are taking the area because we have to find out the displacement. Velocity, area of velocity versus time graph gives displacement. Now you have to plot acceleration versus time graph. So for the plotting of acceleration versus time graph, let's calculate acceleration for certain time intervals, then only we'll be able to observe. Acceleration is what? Change in velocity divided by time. So see, for 0 to 2 seconds, then 2 to 4 seconds, then 4 to 6 seconds, then 6 to 8 seconds, and so on we have to find out. See, 0 to 2 seconds. From this graph, how will I calculate? The slope of the graph will give me acceleration. So it will be what? Slope means velocity divided by time. So velocity is 10, time is 2. So acceleration for the first part will become what? Acceleration, I'll write down here. Acceleration here will be 5. Why? 10 divided by 2. Fine. Now see, here the slope is constant. Slope is constant means acceleration is 0. Again, this will be what? This is decreasing slope from 4 to 6. So this time this will be, if you see the slope, this time it will be minus 10. You will inverse it because this is a decreasing slope. So magnitude will be the same, 10 by 2, that is 5. But here the acceleration will be minus 5. Why? Because final velocity is 0 here. Are you able to see this 0? And initial velocity was 10. So final minus initial gives you negative meter per second square. Then from 6 to 8 seconds, again, this is what? This is minus 10 here. Initial velocity is 0. So 0 minus minus 10 makes it minus 10. So here also acceleration comes out to be minus 5 meter per second square. Here acceleration it will be plus 5 meter per second square. So we have just calculated the magnitude just to check whether the graph will be, how the graph will look like. So see, for this part, let's say we have the magnitude as 5. We know the magnitude as 5. So for plotting such graphs, do one thing. Let's say this is plus 5 meter per second square. This is minus 5 meter per second square. This is acceleration. This is time. So divided into the same interval, 0, 2, 4, 6, 8, and 10. These were the seconds. So 0 to 2 seconds, it was 5 meters. So see how the graph will look like. 0 to 2 seconds. This is 5 meter per second square only. So this will be 5 meter per second. Now 2 to 4 seconds, it was 0. So acceleration will be 0. Then 4 to 6 seconds. 4 to 6 seconds, it was minus 5. So this will be for 4 to 6. You just draw it dottedly. This is the main graph. No, this is the main graph. This is the main graph. These dotted lines are just showing in which time interval they are lying. So 6 to 8 seconds are also negative. And then this is positive for 8 to 10 seconds, like this. This will be the graph of acceleration versus time for the same question that was given, for the same question. Fine, so note down it. If you have any queries, ask me. Then we'll start with the test. Take a break of 5 minutes. After exact 5 minutes, I'll start with the test. Aram, I've received your answer sheet. Fatima, are you there on the WhatsApp group? Then submit the sheets on the WhatsApp group only. All of you send your answers on WhatsApp only as you complete it. And just cross check it with me once you've submitted. Aisha, I've got yours also. Fine, you can also do it. Maha, you're not there on the group, WhatsApp group.
Yes, ma'am. There.
Then submit there only on the group only. Just submit it on the group.
Okay.